product update. Today, I'm going to share with you some general information about the aerobic systems within Nijhuis. My name is Tanya Georgieva, and I'm a product manager responsible for the secondary treatment and particularly for the aerobic systems. So I will start the introduction with a general overview of the systems which are within Nijhuis or industries available, which we are designing on, and we are currently developing, but also we are working in the research and development group for removal of COD, nitrogen, and phosphorus. On the first slide, you see an overview of these systems, and namely those are the Bioreactor, SBR. Most of you probably are aware of the sequencing batch reactor system, but also of the traditional continuous activated sludge process. We also have in our portfolio the Bioreactor Hrnr, which stands for the high rate nitrogen removal process. I will go later more in details about that system, but also the Mbr, the membrane bioreactor, and Mbr, the moving bed biofilm reactor. Last but not least, the botanical garden, which will be for this moment not going into details, but there will be more information. If you require, you can contact me as well. And I would like also to mention one specific unique selling points for these systems is the flex aeration, the aeration system designed by Nijhuis. What are the drivers to select a specific Bioreactor technology? And in this overview, I would like to point out the main drivers. The continuous system is already well applied, a conventional system, which typically is for the removal of the bulk organics, nitrogen and phosphorus, pollutants from the wastewater, so typically supply for a high volume stream but a low pollution load. The same counts for the SBR, the sequencing batch reactor, with the difference that the SBR is applied in productions which are, or industries which are not having a continuous discharge of effluent and not continuous operation systems. So that's why it's usually applied for a lower volume streams. The Mbr system, so the moving bed bioreactor system, is also a very well-known and applied system in various of industries and also a high volume and low pollution load. The difference with the continuous system here is that if there are food restrictions, that's a very good alternative because the Mbr system is a very compact one. The Mbr system you can always consider when there are requirements for a very high effluent quality, and especially for reuse application, because the membranes are ensuring very low suspended solids level in the treated water. Last but not least is the Hrnr system, which is more specific one because it's only applied for a high nitrogen load effluent streams or streams which contains up to 1.5 gram nitrogen per liter. It's also a very beneficial system if we have streams with a high temperature, above 30 degrees, and if there are also footprint restrictions, because it's also a very compact one. Today we are going to focus more on the last three, which I mentioned, the Mbr, Mbr, and Hrnr process. First, we start with the technology explanation of the moving bed biofilm reactor. And as I already mentioned, this is a biological system, typically consisting of aeration tank for the organic removal, but if there is a requirement also for nitrogen removal, an anoxic tank can be installed as well. What is specific for this system is actually the design with the plastic carriers, and Nijhuis is currently using two types of carriers. One is the Nijhuis biochips and the Nijhuis biocarriers. What happens is that the sludge, the bacteria, is actually growing on those plastic carriers, and a big or very high amount of sludge can be retained in a very small amount of tank volume. That's what makes the system very compact, and that's one of the biggest benefits of this system. But not only that, the less sludge production compared to the activated sludge process is a very important benefit. but also that there is no sludge return. It's a very also stable process because it requires only one main control parameter, and that's the oxygen. But what is also specific for the Nijhuis solar industry Mbr system is that we designed the system with special overflow screens which retain the carriers with the sludge on them inside the tank, and they cannot escape with the effluent treated water. But also the optimized aeration system, which is a coarse bubble aeration with a zero maintenance required. And if we combine the Mbr system with the DAF, then we can ensure a very low TSS content in the effluent. Well, what differs typically one Mbr system from other is in fact the carrier materials. And the Nijhuis biochips has a huge surface area between 2,250 up to 3,500 square per cubes. And that comparing to the most of other carrier suppliers, as you can see, is around 650. What does it mean? The surface area is actually the area on which the bacteria grows. That means that it makes the system very compact because a lot of bacteria can be retained on only one biochip comparing to the others. We extensively also use another type of biocarriers on the second picture, as you can see, and it has a lower surface area, but also has an advantage of this open structure, which does not allow any clogging of the carrier with the biomass. There are many suppliers of carriers, and here I show only two just to see the difference in the shape, in the form, in the structure, and they all have advantages and disadvantages. Well, currently we are discovering and we are working closely with the R&D department on making a more extensive overview and characteristics, and we are performing a lot of lab research on what's the benefit of our comparing to others, but mainly that's the surface area and the open structure of the second biocarrier Nijhuis chips. So one interesting reference which I would like to share with you here is on the project in Poland, Orlen, and the starting date officially was 2020. It's a refinery wastewater treatment with a capacity up to 4,000 cubes per day, where we have a total solution integration and MBBR also designed with the Nijhuis biochips, which is currently in operation. I will move further to the Mbr system, so the membrane bioreactor. And what is the most important here to remember is that this is the traditional biological system, but the only difference comes from the solid liquid separation, which is carried out in that case by membranes. On the picture here, you'll see actually submerged membranes, which are already installed into the biotank, but they can be also installed in a separated, dedicated tank. And what we have currently as a solution within Nijhuis is we have the traditional submerged flat sheet membranes, which you can see on the right picture, but we also design our system with the crossflow MBR with the low speed crossflow and low speed crossflow UF membranes. So what are the main benefits? The first one is that the membranes are ensuring very, very high quality of the effluent with no TSS content, and also with the possibility for reuse applications. The system is very compact and is very flexible because it can be also installed in existing infrastructure. There is no polymer dosing required, but there is also no sludge return when actually the membranes are installed into the biotank. If the membranes are separately installed, then a sludge return should be considered. In general, this system has a very large application because it can be installed both on both upstream and downstream process, but also is very flexible in operation. Last but not least, there is also a huge experience within SOAR France, over 40 references, mainly in the municipal market, that should be really considered because there is also extensive knowledge and experience with different membranes types and brands. One example of Nijhuis industry reference is a project in Poland, again, part of CDROP Duda, where this system is in operation since 10 years ago, from 2010, and it's in the red meat slaughterhouse industry with a design flow of 1,500 cubes per day. You can see pictures from the site here where we use, and the system was designed with the submerged flat sheet membranes, and existing infrastructure was used. The existing SBR tanks were transferred to Mbr, and that increased the capacity of the total plant. Finally, the effluent is discharged to the river, completely free of solids. And last, I would like to give a little bit attention to the very interesting process called Hrnr System. So this is high rate nitrogen removal. This is a more specific system because it's applied mainly and actually mostly for nitrogen removal, high nitrogen content, but up to certain limit, up to 1.5 gram of nitrogen per liter. And what is very interesting here is the type of bacteria. It's called Anamox bacteria. That's why also the process sometimes referred to Anamox process. It's a very distinguishable one because it has a very bright red color, as you can see on the picture, and it grows in flocks. This type of bacteria has, together with other types, so a whole group of bacteria together with the Anamox bacteria, are cutting part of the nitrogen conversion from ammonium to finally nitrogen gas. And also very specific is that it's operated only under high temperature, minimum 30 degrees, and a COD to total nitrogen ratio below 1. That means that the system cannot be applied on the mainstream flow, but actually on the side stream. For example, for treating centrate out of the digesters where the temperature is still high, so we take advantage of that, but also the COD, the organic level, is lower. So with this specific type of bacteria, which I mentioned that they are having a different conversion compared to the traditional nitrification, denitrification process, one of the benefit and main benefit is the low energy requirement. Compared to the traditional nitrification process, here only 50% of the air is needed. But not only that, also no external carbon source is required like with the denitrification process. And last but not least, the low sludge production. But what is specifically the USP of Nijhuis Hrnr system? That's the sludge separation. What we use and how we design the system is with a DAF, and the role of the DAF is to separate first the group of bacteria from the treated effluent, from the treated water. Further, not only that, we also design a screen, a filtration step, where we separate specifically the Anamox bacteria, because we need to keep it in the tank, and that's a very slow growing bacteria, so should be there. But we can be also flexible if there's a footprint restrictions and the DAF cannot be installed. We can only design the system with screens, but then we just need to consider an additional or optional, it's not always the case, optional polymer dosage. So we made an overview of the main players, main competitors within this system. And Pax and Veolia have an extensive already experience and a lot of references with their Hrnr systems. They are very similar in our, comparing to our design in terms of nitrogen loading and the MLSS content. But we should not also underestimate others such as Demon and Sweco, which were used to be a company together, but now they separated, and the only difference between them is actually only the separation of the Anamox bacteria when where Demon is designing the system with hydrocyclone and Sweco with screen. Coulson is a Dutch company where we still do not have so much information for, but they also have a number of references. So finally, to finish my presentation, I would like to point your attention to the fact that we have all the solutions, biological solutions within our house, within our group, but every case is specific, so it's important to remind these are general statements, but it always has to be consider different alternatives. Well, please, if you have any questions, contact me further, but I would like to keep your attention to the take-home message that we can comply with all clients' requests, and especially in different industry applications with our aerobic treatment bioreactor. Thank you for your attention.